In order to evaluate an angle that does not lie in quadrant 1, in other words, an angle that lies in either quadrant 2, quadrant 3, or quadrant 4, we must first determine its reference angle. A reference angle is an acute angle. Remember, an acute angle is an angle that's less than 90 degrees. Theta prime, which is just theta with a little accent, formed by the terminal side of theta and the x-axis. Recall that an angle in standard position is an angle that starts at the x-axis, positive x-axis, and has an ending or terminal side. Here it is in quadrant 2. In quadrant 3, the terminal side is located here, and in quadrant 4, the terminal side is located here. Next, we need to form a right triangle with the x-axis. So in quadrant 2, we'll form a right triangle with the x-axis. We'll do the same thing in quadrant 3 and in quadrant 4. Now we need to determine theta prime. Theta prime is located here in quadrant 2. It's located here in quadrant 3 and here in quadrant 4. More specifically, it measures this angle in quadrant 2, this angle in quadrant 3, and this angle in quadrant 4. How we calculate the reference angle theta prime depends upon the quadrant in which the terminal side of the angle lies. So simply, theta prime is just the difference between the x-axis and the terminal side of the angle in which the angle lies in that quadrant. So in quadrant 2, theta prime is 180 degrees, which is on the x-axis, minus theta. Remember that our x-axis is either 0 degrees or 360 degrees if we go one revolution around, or if we're using radians, it's going to be 0 radians or 2 pi radians. On the negative axis, we're going to have 180 degrees if using degrees, or pi if we're using radians. In calculating the angle for quadrant 3, it's going to be theta prime equals theta minus 180 degrees. Since the terminal side has gone past the x-axis, we're going to subtract 180 degrees from theta in order to determine the reference angle. The reference angle should always be positive. You should never have a negative reference angle. In quadrant 4, because we don't want to have a negative reference angle, we're going to label the x-axis 360 degrees instead of 0 degrees. So our reference angle theta prime will be 360 degrees minus theta. We could do the same analysis using radians. In quadrant 2, theta prime would be pi minus theta. In quadrant 3, theta prime would be theta minus pi. And in quadrant 4, it would be 2 pi minus theta. Go ahead and pause the video and take a minute to study reference angles. In the next video, we're going to use what we learned about sines and reference angles in order to evaluate trig functions in all 4 quadrants within the unit circle.